Hello everyone. In this particular video, we are going to solve the problem number 1.49 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. A solid body rotates about a stationary axis so that its angular velocity depends on the rotation angle phi, as omega is equal to omega naught minus a phi, where omega naught and a are positive constants. So let us say this is a solid body which is rotating about an axis that is passing through this particular point, and that axis is the stationary which is not moving. Okay, and omega is given as omega is equal to omega naught minus a phi, where omega naught and a both are positive constants and phi is the rotation angle and omega is the angular velocity. It is also given that at the time moment of t is equal to 0, the angle phi is equal to 0. So at t is equal to 0, angle phi is equal to 0. So let us first understand what is this phi and omega. For example, if we consider any point in this particular body, let us say this particular point, then this particular point is moving by the angle about this stationary axis by an angle of phi, and this angular velocity depends upon this particular phi. Okay, but in the problem it is asking to find the rotation angle and the angular velocity as the function of time, not as a function of angle. Okay, so from this we can write omega as d phi by dt, that is rate of change of angular displacement is equal to angular velocity. Omega naught is constant minus a is constant times phi. Now on the right side we are having the function of phi. Okay, so in order to find the phi as a function of time, we have to take the entire function to this particular side and dt to the opposite side. So we can write from here d phi whole divided by omega naught minus a times phi is equal to dt. Let us integrate both the sides from t is equal to 0 to t. At the time instant of t is equal to 0, we are having phi is equal to 0 as it is given in the problem, and at the time instant of t we are having a phi is equal to phi. Okay, now for this particular integral in the left side, let us say we are having the function that is dx whole divided by a plus bx. If we take the integration of this particular function, then the integration of this function is 1 upon b times ln of a plus bx mod. Okay, similarly we can do the integration of omega naught minus a times phi. So we can write minus 1 upon a ln of omega naught minus a phi from phi is equal to 0 to phi, and in the right side the integration of 1 is t, so we can get t from t is equal to 0 to t. Okay, let us substitute the upper limit and the lower limit in this expression, then we will get minus 1 upon a ln of omega naught minus a phi minus ln of omega naught is equal to t. So from here we can write ln of omega naught minus a phi whole divided by omega naught is equal to minus at, because ln of a minus ln of b is equal to ln of a by b. Okay, so if we take the anti-log of above expression, then we will get omega naught minus a phi whole divided by omega naught is equal to e to the power minus at. Okay, so let us divide the numerator by omega naught, so we will get 1 minus a by omega naught into phi is equal to e to the power minus at From here we can get a by omega naught into phi is equal to 1 minus e to the power minus at. So we can write phi is equal to omega naught by a times 1 minus e to the power minus at. So this is the expression of phi as a function of time we got. Okay. Now if we talk about the angular velocity as a function of time, then we are having the function of angular velocity as a function of angle. So we can write omega is equal to omega naught minus a times phi. Let us substitute the value of phi from here to this particular expression, as we have already obtained the value of phi as a function of time. So we can write omega is equal to omega naught minus a times omega naught whole divided by a into 1 minus e to the power minus at. So from here we can write omega naught minus omega naught times 1 minus e to the power minus at. So here omega naught and omega naught will get cancelled and we will get omega naught times e to the power minus at. So here also we got the angular velocity as a function of time and the rotation angle as a function of time. This is what the question has asked. I hope the entire procedure is clear. Thank you.